Swinburne Podcasts.
So I'm an observational astronomer, so I'm much more geared towards going to the telescope and taking the data, bringing the data back to the computer here at Swinburne and analysing it, trying to figure out what it all means, and then other people in the collaboration will try and make theories or models to fit the data.
My job is to explain what is seen through the telescopes, and specifically is to try and simulate it on a computer. So I'm good at looking at the gas flow between stars and modelling stars forming and planets forming. So once someone has seen it, then I'll try and model it. Well, if you're looking at an object in space, essentially it's a point, and you can get so much information from your observations, but it's almost like you need the simulations to join the dots, to connect one observation with another and to fill in all the gaps and to turn basically one-dimensional information into a three-dimensional object. You need to be able to simulate it. Theory sometimes lags behind observation, and there's always some wacky new object out there that we just don't know, like pulsars with little green men for ages. But you need both sides of the coin. You need people to look, you need people to explain.
Well, a few years ago we had a paper published in the Science journal. There we started with some images from the Hubble Space Telescope, where we noticed a curious sort of small galaxy looked like it was being stripped apart of literally having its stars taken off by a larger galaxy. So in some sense eaten or cannibalized by this larger galaxy. To confirm that, we needed to go to the Keck telescope, which is the world's largest, to obtain the distance and confirm that the two galaxies were physically associated with each other. So we did that, and indeed they were. We also brought in a colleague from the University of New South Wales to do some computer modelling for us, to try to model the system. So once we'd determined the relative masses or sizes of these two galaxies, the dwarf and the larger giant galaxy, he was able to put this into his model, and indeed it looked just like the image that we had from the Hubble Space Telescope. So one of the nice things about the computer model is we could look at what the little galaxy looked like before it got too close to the big galaxy, and also what was going to happen to it in the future. Turned out, of course, it was going to be completely disrupted in a few billion years' time, which is quite short by astronomical timescales.